Welcome to another podcast. In this episode, we're going to be taking a look at how to do counting problems that involve the word OR, which means they involve the operation of the set union or set addition, if you want to call it that way. What's unique about this particular podcast from some of the other ones you've watched is I'm going to give you a glimpse into two different word problems, specifically designed to showcase some of the counting skills that we've already developed, specifically multiplication rule. We've started looking at permutations and combinations as well. And so this is going to give you a sort of a sneak peek into how you bring everything together to help solve a problem. So we're going to start with this first example. And in this example, we're looking at 8-bit strings of length 1, of length 8, since it's an 8-bit string. And so essentially what we have here is a slot diagram containing 8 characters. So our slot diagram looks something like this. And each slot would have the ability to have two objects in it, either a 1 or a 0. And so all totaled, this set, which I'll consider U the universal set, has 2 to the 8th, or 256 total possible rearrangements of the 1s and the 0s. So whatever we're dealing with, the number's got to be less than 256. We know that at least. Let's consider what the individual sets themselves are. The first set we have to consider are all those strings that start with 2 1s. I'm going to call that the set A. And then we will also need to consider all strings that end with 0, and I'm going to consider that the set B. So if I'm looking at the set A, let's think about what its slot diagram would look like. You're starting with 2 1s, so we still have 8 slots here. But because the first 2 slots have to both be 1s, you're locked into only one choice. So don't confuse the 1s that I put in those blanks with the actual number 1 in the string. It represents one choice. Each of those first 2 blanks, I only have one choice. They have to be 1s if they're going to belong to the set A. All of the rest of the slots would have 2 choices, either 0 or 1 in set A. That leaves a total of A having 2 to the 6 possibilities according to multiplication rule. That's what we're using here. 2 to the 6th, which, let's see, 2 to the 6th would be 64. So there are 64 total possibilities for the set A. Okay, the set B is the set that contains all the strings that end in 0. So there are 8 total slots here. Ending in 0 means I only have one choice for that last slot. It has to be a 0. And all the other slots I would have 2 choices for. So that means that the set B has a total of 2 to the 7th, or 128 choices. Okay, let's try to do addition rule now. The reason that we know it's addition rule, once again, let's make sure that we're all aware of that, is the word OR. Anytime you see the word OR, you should be automatically thinking of the union operation, so A union B. Take from A, take from B, add it together, get rid of any of the overlap. So if I go and try to calculate the size of A union B, which is what this problem is asking us to do, addition rule says it's the size of A plus the size of B minus the size of their overlap. Now we know what A is, it's 64. We know that B is 128, but the question here is, what is A intersect B? And what does that even mean? Well, A intersect B as a set, you should think of the intersection as the word AND. So to belong to the set A intersect B, the strings have to obey the rules for A as well as the rules for B. And so what that means is the string that we're looking at here will have 8 characters, but like A, the first 2 slots have to be 1s, and like B, the last slot has to be 0. That means those 3 slots, the choices have already been made for us. If you look at everything that's left, I've got 2 choices for these slots, and there are 5 of them. So A intersect B in this case is 2 to the 5th, or 32. If we fill that into our addition rule formula, and we add down, then that gives us a total of 160 strings. So the answer here is 160. Alright, so the main counting tool that was used there was the slot diagrams in conjunction with the multiplication rule, But the problem as a whole, we had to do addition rule to find it. So it's a lot of mixing of the methods that we've studied so far in the course. Moving on to example 2. Example 2, I need to identify my sets as well and identify the counting tools I'm going to be using. The first set is exactly one freshman, so I'll call that set A. And the next set is exactly 2 women, and so I will call that the set B. Now, what you notice about this is it fits all the properties of a combination problem. Remember, if it's a combination, then there's 2 things I've got to check. The first thing I've got to check is order. In this case, order does not matter, so we're good. The order cannot matter. And then the second thing I have to check is repetition. I can't repeat. There should be an E there. My spelling is not that great. So repetition shouldn't be allowed either, and in this case it's not. I can't pick the same person twice to be on the committee. So different people are being chosen. The order in which they're chosen doesn't matter. Both of those conditions are met. So it's a combination problem. The question is, how do we count each set? So let's start with the set A. The set A consists of exactly 1 freshman, which means from the 8 freshmen, I'm going to choose 1. And from the 6 sophomores, I'm going to choose, well, how many? Well, I need a committee of size 5. If you look at the problem description, the committees are size 5, which means that I've only picked 1 so far. I need an additional 4 people to fill up the committee. So from the sophomore group, I have to pick 4. So C8-1 and C6-4. I will calculate this here in a second. I'll bring up the calculator and we'll look at the value for that. But for now, let's move on to set B and see if we can figure it out. Set B has exactly 2 women. So picking from the women, how many women total are there? There's 3 from the first group and 3 from the second group. So there's a total of 6 women. And out of those 6 women, I need to choose 2. Now, to fill in the rest of the committee, there's 5 people, so I need to choose another 3 from the men. And there are a total of 5 and 3, or 8 men. And so 8 men, and I need to choose 3 from that group to fill up the rest of the committee. There's one thing that I want you to notice here about doing these problems, and that is if you take the second number in each case, it adds up to 5 because that's how big the committee is. That's something you should sort of keep track of when you're doing these combination problems and permutation problems for that matter. All right, let's bring up the calculator here and see how big to make these. Remember, you can search in your catalog for the function that we want, and in this case that function is NCR since this is combinations. And so NCR, let's do set A first, is NCR 8-1, and then NCR 6-4. So that's 120 for set A. Set B is NCR 6-2 times NCR 8-3, and that's 840. So let's remember those 2 values, 120 and 840. So for the first one here, we've got 120, and for the second one here, we've got 840. Okay, now it's time to see if we can finish out the problem. Once again, this is addition rule, so A union B is equal to the size of A plus the size of B minus the size of the intersection. The size of A is 120. The size of B is 840 minus the number in both. Okay, so what does it mean to be both in this problem? Both A intersect B would be both having exactly 1 freshman and having exactly 2 women. Now, that is a difficult thing to figure out. And the reason that that's difficult is because the freshmen can be women. So how would you go about doing this problem? I want you to think about this, what goes here for this example. Now this is much harder than what I would give you, but I kind of want to challenge you here. So I want you to think about this. Think about what should go in the A intersect B box for this problem. It's exactly one freshman and exactly two women. That's what A intersect B would be. A intersect B would be one freshman and two women. So how many ways are there to do that? So you basically got a grouping of 5 here, and we need to figure out how we'd go about doing that. So if anyone can come up with the answer to this, I would love to hear your response on it. But this is basically the way that we would handle this problem. We would take the 840 and the 120, get 960, and then we would subtract out whatever the size of this set is. Question is, can you figure it out? And so I'm going to leave this an open-ended question. I want you to try it. If you think you have the answer, come up to me sometime in class and see if you know how many freshmen and two women groups are possible to make here. All right, I hope this has sort of given you a hint at how to go about doing these problems. I just wanted to take the opportunity to kind of put it all together for you. We're going to do one more video of these counting methods involving complements, so I hope you tune into that video as well. Thank you for watching.